Green energy in ports. Decarbonizing the powerhouse of global trade with secure IoT, virtual power plants, and artificial intelligence. Ports and their authorities are key to reducing the maritime industry's environmental footprint. They must enable and create a comprehensive system within the maritime port that facilitates data sharing and uses renewables, carbon-neutral fuels, energy storage technologies, microgrids, advanced digital energy systems, digital twins, and more. Port capacity planning and optimization efforts must be aligned accordingly. Lower energy costs and less emissions for ports. Studies suggest that via renewables and digital energy systems, ports can lower their energy costs by more than 30%, and GHG emissions can be reduced by 20% to 80%. This depends on the extent of green energy measures deployed, and the spectrum of such measures is vast. Ports are extensive energy hubs and central nodes for sector coupling, powering everything from terminals and bridges, ships, buildings to lights, buoys, trucks, railways, and more. This carbon-neutral energy keeps ships operational and supports a wide range of industries such as refining, transportation, steel, metal, tourism, and more. Digital is the key driver for decarbonization. Ports are going digital to achieve carbon neutrality. This involves port authorities making use of and investing in advanced digital technologies. These support to manage all energy operations, both inside the port and connecting to surrounding ecosystems, including required data sharing efforts. Some big energy challenges ports are tackling: dispatching and balancing the energy use within the port, seamlessly connecting to the electrical grid, optimizing energy efficiency, and finally, making the switch from fossil fuels to carbon-neutral energy sources. Cold ironing, automation in port services and operations, peak shaving or load shifting are energy and carbon optimization measures already deployed in some ports. Ports should focus on 3 key technologies. To stay competitive, ports and their authorities must adopt 3 advanced technologies. IoT and IoT security are core technologies ports deploy to combine the physical and digital world and generate and acquire the data needed for all further optimization and automation steps. Port IoT capabilities must include 1. Interoperability across technologies, data formats, and different data systems. 2. Governance to manage access and usage of data assets generated and owned by different port stakeholders. 3. Flexibility and scalability to avoid vendor lock and poor service quality. As data from IoT devices is growing exponentially and becomes mission critical, OT security and OT and IT convergence becomes a major challenge. New standards, such as the Trusted Energy Interoperability Alliance, and technologies such as explicit private networking, XPN, deliver new levels of port data security and interoperability. The port's virtual power plant acts as a smart energy manager, optimizing power usage within and beyond the port. It leverages the combined power of various distributed energy resources like wind, solar batteries, both stationary and vehicle-based, backup generators, heating, cooling, and commercial and industrial energy loads. By participating in local electricity markets and wholesale transactions, the port's VPP can create revenue for ports and those who connect their energy assets to the system, while also reducing electricity costs. The use of renewable energy can be boosted and therefore also the port's decarbonization performance. Studies suggest that with the right mix, ports can lower their carbon footprint to almost zero. Artificial intelligence is becoming the brain behind VPPs and energy systems, analyzing a constant stream of data from port sensors and external data sources. This data empowers AI to recommend optimizations or even automate actions, streamlining port operations. As the complexity of energy management grows, AI will play a central role. Reinforcement learning, a very powerful AI technique, holds the promise of creating self-optimizing energy systems within ports, taking efficiency to a whole new level. Capacity planning and port optimization. In response to growing environmental concerns, ports are facing the task to minimize their carbon footprint and align capacity planning and optimization efforts. Fortunately, a multifaceted approach utilizing innovative technologies offers a promising path towards a more sustainable future. Key to this transition is the strategic investment into solutions like IoT, VPPs, and AI-driven optimization. Overall, green energy and decarbonization offers significant opportunities and benefits to ports.